Hi everyone. In today's lesson, I'd like to review the concept of rational functions. You learned these in Algebra 2 and again in pre-calc, but it's important for us to understand the fundamentals of rational functions before we move on to graphing them. So today we're going to review all the components, and then tomorrow we're going to graph them by hand using the first and second derivatives. So the most basic rational function is the form f of x equals 1 over x. Rational meaning a fraction. So any type of function that has a fraction is called a rational function. And rational functions have undefined values, and that's where the denominator is equal to 0. So to find the undefined value, you literally take the denominator and set it equal to 0. So in this case, the denominator is x, so we set x equal to 0, and x is the value that makes the fraction undefined. So the domain of this function will always be all real numbers. So we use this symbol to represent all real numbers. So the domain would be all real numbers except for when the values are undefined. So except for when x is equal to 0, because that's where the graph does not exist. So let's just show you what this would look like in terms of a graph. So say you have an xy axis like such, and I want to graph this y equals 1 over x. So I'm just going to show you what it looks like. We'll worry about the graphing tomorrow. But it has a branch on this side in the first quadrant, and then it has this other branch on the third quadrant. So these branches make up this rational function where we have asymptotes. So the graph is actually approaching both the x and y axis, but not exactly touching it. So this dotted line that I'm drawing here is the line y equals 0. That would be the horizontal asymptote of this function. And this dotted line that I'm drawing over the y-axis is the line x equals 0, which would be the vertical asymptote. Now, sometimes you may have holes in rational functions. There are no holes in this specific graph, but a hole would just look something along those lines, and that's what the idea of this function would be. So let's talk about things like the undefined values, the horizontal and vertical asymptotes, and then the holes. And that'll give us a good head start on tomorrow for when we're going to use the first and second derivatives. So what I'd like everybody to do right now is log on to the Delta Math, and you will see two examples, and I'd like to do the first one with you. So the first one here says determine each feature of the given graph. So the first thing I'd like to do is find the horizontal asymptote. Now, you know how to do this already. Horizontal asymptotes are found by taking the limit as x approaches positive or negative infinity. So what that means is that we're going to analyze the degree of the numerator and the degree of the denominator. So remember those three limit rules. The degree of the numerator is equal to the degree of the denominator. Then in this case, we said the limit was the line y equals 0. Oh, excuse me, the limit was the ratio. So the limit here is the ratio of the coefficients. If the degree of the numerator is less than the degree of the denominator, then the limit is the line y equals 0. And if the numerator is greater than the denominator, then there is no horizontal asymptote, but a slant asymptote. So let's just look at the situation. So the degree of the numerator, there's an x there, so the degree of the numerator is 1. The degree of the denominator is 1. So if we take the ratio of the coefficients, 9 is our first coefficient, and 16 is our bottom. So our limit, or horizontal asymptote, is going to be y equals 9 over 16. And that would be our horizontal asymptote. So that would be this category, okay? Now let's move on to vertical asymptote. So same problem, but now vertical. So the vertical asymptote and the holes are related. So you can't find one without the other. So the first thing that you're going to do is you're going to factor. Factor any top or any bottom. So let's look at the numerator. Looks like I can factor out a GCF of 3, so I'm going to go ahead and do that. And then I'm left with 3x plus 10. And then in the denominator, it looks like I could divide out a GCF of 4. and I'm left with 4x minus 11. Now, what happens here is that nothing cancels on the top. So if something did cancel, we'd cancel it out and then simplify it. So since nothing cancels, that means there are no holes. So go ahead and click no holes. So the reason why, again, that there are no holes is because nothing cancels. So if something canceled, then that would be the hole, and I'll show you that in the next example. So for now, this example, please select no holes. So you should still have your horizontal asymptote of y equals 9 over 16, no hole, and now let's find the vertical asymptote. So the vertical asymptote is found by setting any leftover denominators equal to 0 and solving. So we're going to take our denominator, we're going to set it equal to 0, and we're going to solve. And we're going to do a t-chart. 4 equals 0 makes no sense, so we get to reject that one. And then we're going to set 4x minus 11 equal to 0 and solve. So we'll add the 11 on both sides, and we'll divide the 4. So we have x is 11 over 4. So this is going to be my vertical asymptote. So x equals 11 over 4 is the equation of my vertical asymptote. All right. Then last but not least are our x and y intercepts. So remember, x-intercepts are found when we set y equal to 0, and a y-intercept is when we set x equal to 0. So in x and y intercepts, we always have to use that simplified equation. So from the previous slide, we took out a 3, and we have 3x plus 10, and in the bottom, we took out a 4, so we have 4x minus 11. So when we're finding our x and y intercepts, we're going to use this equation. So y equal to 0 first. Remember, if we have 0 on the left, we can put that over 1 and cross multiply. So 3 times 3x plus 10 is equal to 0. And we could just do a t-chart. So 3 equals 0 makes no sense. We reject that. And 3x plus 10 equals 0. We'll subtract 10 and divide by 3. So we'll get x equals negative 10 thirds. So if we put it into an intercept, negative 10 thirds, comma 0. Notice how they already have the comma 0 for you. And then the y-intercept is found by plugging x into 0. So y equals 3 times 0 plus 10 over 4 times 0 minus 11. So 3 times 10 over 4 times negative 11. So 30 over negative 44, which reduces to 15 over negative 22. So as a y-intercept, it's the point 0, comma, negative 15 over 22. So negative 15 over 22 should go in for my y-intercept. So just to clarify before you finalize your answer into Delta Math, your horizontal asymptote was the line y equals 9 over 16. Your vertical asymptote was x equals 11 over 4. There were no holes, so you have to click that button. And then those should be your final answers for the Delta Math. So go ahead and type those in, and you should get a nice green check mark. And then I'd like to move on to the next example. Okay, so let's find the horizontal asymptote first. So remember the 3 rules. If the degree of the numerator is equal to the degree of the denominator, then the limit is the ratio of the coefficients. If the degree of the numerator is less than the degree of the denominator, then the limit is the line y equals 0. And if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. So let's see what we have. The degree of the numerator is 1, and the degree of the denominator is 2. So therefore, the degree of the numerator is less than the degree of the denominator. Therefore, the limit, or the horizontal asymptote, is the line y equals 0. So that is all you need to put in there. Okay, now let's find the vertical asymptote and the whole. Remember, these two go hand in hand. So first we're going to factor. We're going to factor the numerator and we're going to factor the denominator. So the numerator, I could take out a GCF of 4 and I'm left with x minus 2. In the denominator, we're going to figure out add, multiply. What multiplies to negative 2? That adds to negative 1. And that is x minus 2 and x plus 1. So now in this example, you're going to notice the x minus 2's cancel. So we have a new simplified equation of 4 over x plus 1. So since the x minus 2 was canceled out here and here, the opposite value of that will be my whole. So basically, what you want to consider here is this denominator. So you have x minus 2 and x plus 1. If we were to set this equal to 0 and find the undefined values, we would get 2 and negative 1, right? So since this x minus 2 was canceled, that means this x equals 2 is the x value of the whole. And the values that are left over are my vertical asymptote. So in this example, this negative 2 canceled, so the opposite sign is the x value of my whole, and the stuff that's left over is my vertical asymptote. So we actually can go ahead and say my vertical asymptote is x equals negative 1. Remember, it's an equation, right? Now, to find the value of the whole, we know the x value of the whole is 2, but to find that corresponding y value, we have to plug 2 into the simplified equation right here. So we're going to take 4 and x plus 1, but instead of x, we're going to put 2. So 2 plus 1 is 3, so we get 4/3. So that 4/3 will go in for my whole. Now you cannot plug the whole into your original function, because if you do, say I put 2 in here, 2 minus 2 gives you 0, and it's undefined. So the idea here is that we have to factor and cancel. The value that canceled is my whole. The stuff that's left over in the denominator is my vertical asymptote. Okay? So x and y intercepts, same concept as before. We're going to plug into my simplified equation. So remember, we took out a 4, and we have an x minus 2 and an x plus 1. So our simplified equation was 4 over x plus 1. So to find the x-intercept, we're going to set y equal to 0. So 0 over 4 over x plus 1. We're going to put the 0 over 1 and cross multiply. So here we get 4 equals 0. Now, this doesn't make any sense. That means there is no x-intercept. So we can go ahead and click that button there where it says no x-intercept. And then a y-intercept is where we're going to set x equal to 0. So we've got y equals 4 over 0 plus 1. So 4 divided by 1 is 4. So my y-intercept is the point 0, 4. All right. So just to finalize everything, our horizontal asymptote was the line y equals 0. My vertical asymptote was the line x equals negative 1. And my whole was 2 over, 4/3. So that is your final answer here. So go ahead and submit that into Delta Math and you should get your green check mark. And then it's your responsibility to finish the rest of this for homework. And then tomorrow we're going to use this along with first and second derivatives to graph these functions by hand. All right, that's it. Have a great day, everybody.